Hello everybody, this is PRK Physics. Today our topic is calorimetry. So what is the principle of calorimeter? What is the principle of calorimetry means? Suppose in a calorimeter means a copper vessel having some wooden box around it in order to avoid the heat loss to surroundings. In that copper vessel, in that calorimeter, we will use different liquids at different temperatures. Whenever two bodies of different temperatures are in contact, what happens means heat flows from hot body to cold body until the temperature becomes equal. Here the principle of calorimetry is amount of heat lost by the hot body must be equal to amount of heat gained by the cold body. So this is the principle of calorimeter. Sometimes the cold body may be calorimeter, sometimes the cold body may be water. So there may be two cold bodies, one hot body. So that depends upon the given numerical problem. So basic concept, basic core formula for the calorimetry. This is the principle of calorimeter. Provided there is no heat loss to the surroundings, amount of heat lost by the hot body is equal to amount of heat gained by the cold body. So here for heat energy there are two expressions. I think you know, basing on the definitions of specific heat and latent heat. I think you know the definition of specific heat. Specific heat means it is amount of heat required to raise the temperature of a unit mass of substance through 1 degree Celsius or 1 Kelvin. I can write S is equal to Q by M delta T. Suppose if mass is taken as unit and temperature rise is also unity, then taking M is equal to 1, delta T is equal to 1, I can equate S is equal to Q. So definition of specific heat is the amount of heat required to rise the temperature of unit mass of substance through 1 degree Celsius. This is the basic definition of specific heat. I hope you know its units. CGS units of specific heat. Specific heat is for heat, CGS unit is calorie. For mass, CGS unit is grams. For temperature difference, degree Celsius. So calorie per gram degree Celsius. And for specific heat, SI unit. Heat energy means SI unit joules, mass, kilogram, temperature difference, Kelvin. So generally there are no SI units or CGS units for temperature, but in general we will take the temperature units in SI as Kelvin. For temperature difference, Celsius and Kelvin both are equal. In temperature difference, that means 2 degrees Celsius rise in temperature is also equal to 2 Kelvin, because in temperature scales lower and upper fixed points, the gap between lower and upper fixed points in Celsius and Kelvin scale are equal. Okay, we'll discuss about the temperature difference scales relations. I think in the previous video we discussed it. Okay, these are the CGS and SI units of specific heat, and I think you know about latent heat. Latent heat, this definition can be explained only when the change of state takes place. I think you know for a substance there are three different states: solid state, liquid state and gaseous state. So during the change of state from solid to liquid, or during the change of state from liquid to gas, we will use this concept called latent heat. So basing on the definition, I can write like this. The expression for latent heat is Q by M. So it is amount of heat required to rise the amount of heat required to convert unit mass of a substance from one state to another state. The definition of latent heat is the amount of heat required to convert unit mass of substance from one state to another state. So basing on this expression, I can write CGS units for latent heat. For heat energy, I told you calories, and for mass, grams. So calories per gram. And in SI system, it's units, joules per kilogram. So these are the basic definitions: specific heat and latent heat. From this I can write like this: Q is equal to ms delta T. Q is equal to ms delta T. This is the formula for heat energy which can be used when the temperature of the substance changes by supplying heat energy. And basing on this expression, if this denominator comes to left side, I can write Q is equal to ml. So Q is equal to ml. This is the formula of heat energy that can be used during the change of state. So there are two expressions for heat energy you need to remember. One is ms delta T, other one is ml. This expression can be used during the temperature change. Temperature may increase or decrease, but the state do not change. Solid means it has to be in the solid state only. State should not be changed, but the temperature has to be changed. So by supplying heat energy to a substance, if its temperature changes, we have to use this formula, Q is equal to ms delta T. So by supplying heat energy, if the state changes, we have to use this formula, Q is equal to ml. And remember one thing, during change of state, temperature remains constant. Suppose if I give you 10 grams of ice and I am heating it, what happens? Ice will convert into water, that is called melting. So and this process takes place in certain time. That means it will take 10 seconds or 20 seconds. There will be some time interval to convert ice into water completely. So suppose after some time, after 10 seconds or like that, out of 10 grams of ice, only 3 grams of ice is converted. Then means what does it mean? 3 grams of ice convert into water. So remaining 7 grams of ice still there. And after some more time, 6 grams of ice is converted into water. Again 4 grams of ice still there. The temperature during the change of state remains constant. Suppose the ice takes almost 10 minutes to convert completely ice into water. But during this 10 minutes, by supplying heat energy, the supplied heat energy will be utilized only to change the state of the substance. The heat will not increase any temperature. Got it? So during the change of state, temperature remains constant. Only the state changes. And suppose the 10 grams of ice completely convert into water. After that, again still we are continuing to supply heat. Then the water temperature rises. Got it? So during the change of state, temperature remains constant. The supplied heat energy will be utilized only to convert the state of substance from ice to water. Just an example. And if we supply heat energy, if we continue to supply heat energy even after conversion, then water temperature rises from 0 to 100. Got it? So during change of state, temperature remains constant. You need to remember these two expressions. One more thing, you need to remember 4 values, specific heat and latent heat values of ice and water. So what is the specific heat of ice? It is a fixed value. You need to remember it is 0.5. That is in CGS units, means calories per gram degree Celsius. And specific heat of water, fixed value, 1 calorie per gram degree Celsius. You need to remember these values for doing problems. And latent heat of ice value, 80 calories per gram. And latent heat of vaporization, that means steam, its value is approximately 540. We will take in some textbooks, they will give 536, no problem. 540 calories per gram. So these are the 4 values you need to remember. Sometimes he will give you about calorimeter. Calorimeter means generally it is copper calorimeter. Specific heat of copper. In general, this value he will give you in the question itself. Actually its value is 0.09 calories per gram degree Celsius. In some numericals they will give you 0.1 calorie per gram degree Celsius, because very close value, 0.09 is very close to 0.1. So these are the things you need to remember before doing problems or numericals of calorimetry. Specific heat of ice, you need to remember 0.5 calorie per gram degree Celsius. Specific heat of water, 1 calorie per gram degree Celsius. Latent heat of ice 80 calorie per gram. Latent heat of steam is 540 calories per gram. Specific heat of copper calorimeter 0.09, otherwise 0.01 calorie per gram degree Celsius. In most of the cases, we will do the calorimetry problems in CGS units itself. Sometimes in the numerical problems, in the given options, he may mention in SI units. Then we need to convert. How to convert from CGS to SI? Let us discuss about it. Okay, let me clear this thing. Okay.